Alright, this screen recording is to show how to find an unknown weight which might be hanging off to the side here on this, like I say, to the right, or it could have been one to the left on this pulley. But so we're trying to find either the tension in the blue string or this weight hanging here. Same thing since we have one pulley. And we're given this force off to the up and to the right, it's 150 newtons at an angle of 50. And we're also given the weight in the center, which is 170 newtons. So the goal is how do we find how do we find, for instance, this upward component of this force, right? What we'd like to do is we realize that the weight is balanced by an upward component of the red force and an upward component of the blue force in the string. So how do we get those? How do we express those? Well, if we draw a triangle which represents the force vector, right, up and to the left, we realize it's pulling sideways and it's pulling upward. So we're interested in using the y components here. So if we know this angle, we can make that same relationship that we learned about in geometry class, for instance, that the opposite side of a triangle over the hypotenuse is the sine of the angle theta. So the y side is going to be the hypotenuse reduced by sine theta. So the same thing here, we could express this as the hypotenuse sine of theta. And that would be the first force in our equilibrium equation, okay, where all the forces will have to add up to zero because the objects are not moving, okay. Similarly, to express this blue string up and to the right, we know that it's pulling sideways and upward. And if this is the blue string and we know its angle, this side is going to be FB sine theta. And we can express that in our equation right here. So now we've got the red upward component and the blue upward component. And we just, in our equation, show that we would see that gravity is downward, and all of those y forces should add up to 0. Okay? And again, we're looking at just the y components of the forces here. So in this case, if we substitute in what we know, we've got 150 newtons for in our red string, sine of 50. We don't know, we're looking for the blue force, but we know it's at an angle of 30, and our weight hanging down is 170. So this is how we can substitute in what we know. Notice the only thing we don't know is the blue force in the string. But we can solve for that. We just calculate out 150, sine 50 is 114.9 newtons. We know that we've still got our 170 newton weight downward. When we add, or if we take negative 170 newtons plus 114.9 newtons, it gives us negative 55.1 newtons. Okay, do that on your calculator. We have to add that to each side to solve the equation. And then finally divide both sides by sine of 30. And that gives us the blue force by itself on the left. And doing the calculation shows us that it would be 110.2 newtons. So that finds our unknown force. And that's how you do a problem when you have the unknown force off to the side and you're in static equilibrium.